Chemistry chapter 21 theory video 2. We are going to discuss about ionic product of water. Ionic product of water is actually the explanation of about water, where we say that water can act as an acid as well as a base. Now we know that hydrogen or a proton, when donated, if something can donate a proton, it is going to be an acid. If it can accept a proton, then it is a base. Now water can be dissociated. In simple terms, we know that water can be dissociated into H+, that is a proton, and OH minus ions. So in this scenario, we know that water can give away H+, and because it has OH minus, it can accept H+ as well. But that is not how it actually happens. Usually how it happens is H2O, that is a single molecule of water, will donate an H+ to produce an ion known as hydroxonium ion, H3O plus ion. Then H3O plus ion, it has an extra proton. So if something has an extra proton, we know that it is the acid. Then hydroxonium ion and the OH minus ion. So OH minus ion is going to be the base. So we simplify that equation, H2O liquid dissociating into H+ aqueous and OH minus aqueous, as shown here. Right. So then this is what happens when it comes to water. So we write an equilibrium reaction for this. Kc equals H+ aqueous concentration. You know that the square brackets are used to represent concentration, multiplied by OH minus ion aqueous concentration divided by H2O concentration. So because the extent of ionization of water is very low, the concentration of hydrogen ions and hydroxide ions is very, very small. So as a result, we consider that the concentration of water would remain constant, because only a very little amount of water will dissociate. So as a result, we write Kc as an expression using instead of Kc we write Kw, but it is the same thing. That is known as the ionic product of water. Because concentration of water remains constant, we take it as 1. So H+ into OH minus ion concentrations divided by 1 is the same thing. So we get an expression for ionic product of water, which is H+ into OH minus ions. It has a value at 298 Kelvin. It is 1 into 10 to the power minus 14 mole squared dm minus 6. So we use this ionic ionic product of water to find the pH values of different things, and this is actually quite important for us in other calculations. Now because water dissociates into H+ and OH minus ions, that is, one water molecule will dissociate into one H+ and an OH minus ion, we know that H+ ion concentration is equal to OH minus ion concentration. So as a result, we can disregard the we can equate those two. So as a result, we can write Kw to be equal to H+ ion concentration into H+ ion concentration, because H+ ion concentration is equal to OH minus ion concentration. So as a result, we get the final equation Kw is equal to H+ ion concentration squared, because it is the same. Then if you rearrange and if you put that value into H+ ion concentration, we know that H plus ion concentration, we know the Kw value, that is a multiplication of those two. If you get the square root of that, then you will get H plus ion concentration to be 1 into 10 to the power minus 7 mole per cubic decimeter. That is the H plus ion concentration in pure water. So if we know the H plus ion concentration on anything, we can calculate the pH value, and thereby we can get an understanding as to whether it is an acid or a base. Write down a note on this. Ionic product of water. Water has the ability of acting both as an acid and a base. Leave a line and write. Write down this equation. So H2O liquid plus H2O liquid, equilibrium sign, H3O plus aqueous, which is the hydroxonium ion, plus OH minus aqueous, which is the hydroxide ion. So H3O plus, it has an excess proton. As a result, it becomes the acid. Then OH minus ion becomes the base. And H plus is donated by one water molecule to the other. This is simplified as the general equation H2O liquid, equilibrium sign H plus aqueous plus OH minus aqueous. Then the equilibrium expression Kc equals H plus ion aqueous, the concentration square brackets, then OH minus ion aqueous concentration square brackets, then water liquid concentration. In pure water, leave a line and write, in pure water, only a very little amount of water molecules would ionize. As a result, it is assumed that water concentration remains constant, within brackets 1. Therefore, when that taken into consideration, equilibrium expression can be written as Kw equals H plus ion concentration into OH minus ion concentration. Kw is the ionic product of water. Put a dash and write its value at 298 Kelvin. It is 1 into 10 to the power minus 14 mole squared cubic decimeter to the power minus 6, because it is two concentrations being multiplied together. Using this, we can find the concentration of H plus ions in pure water. Because H plus ion concentration is equal to OH minus ion concentration, there is this. Equilibrium expression can be written as Kw equals H plus into OH minus ion concentration. Therefore, Kw is equal to H plus ion concentration squared. Then H plus ion concentration is equal to square root of Kw. Kw value we know that is 1 into 10 to the power minus 14. We get the square root, then it becomes 1 into 10 to the power minus 7 mole per cubic decimeter. I hope you understood. If you have any doubts, please raise questions. Then we move to pH calculations. So now here the hydrochloric acid, 1 mole per cubic decimeter, that's a highly concentrated hydrochloric acid, would have a pH of 0. Then stomach juices, it contains HCl, it would be between 1 and 2, lemon juice 2.3, vinegar it is 3, rainwater around 5, and fresh milk around 6.5. then pure water would be 7, then sea water around 8.5, so that means it is slightly basic. Then milk of magnesia, it would be about 10. Then bent sodium hydroxide, that is industrial sodium hydroxide, would be 14. Now, so this the hydrogen ion concentrations in different solutions is very large. One thing that we need to understand is that not only acids that would have hydrogen ions, because all of these are solutions, and it would contain water. So water dissociates up to some extent, very little amount, but still it dissociates. So that means all these solutions would have H plus ions in it. So as a result, we can assume that it has H plus ions. So if there are H plus ions, it would have acidic nature, but however that H plus ions would be overcome by other OH minus ions, or the proton acceptor. So as a result, that will be the quality that will be shown most. So if we know the concentration of H plus ions, we can figure out the pH value of that chemical. The pH scale was introduced by the Danish chemist Søren Sørensen, and he defined that pH value is the negative logarithm of the H plus ion concentration to the base 10. The negative value is introduced to make the pH values positive in most cases, and it is used to the base 10. You have to use natural logarithm, and then we can actually use this equation to convert pH to H plus ion concentration, or H plus ion concentration to pH value. Write down. pH can be calculated using the formula pH equals negative logarithm of H plus ion concentration to the base 10. This is the formula that you need to write down. Right. So here we have to try to use your calculator properly to get an answer. Here the pH ion, H plus ion concentration has been given as 5.32 × 10⁻⁴ moles per cubic decimeter. So what you got to do is H plus ion concentration has been given. So you put the negative sign, negative logarithm of 5.32 × 10⁻⁴ has to be found. Then you will get the pH to be 3.27. So make sure that you get this answer using the natural way of your calculator, and if you get that answer, then you know how to do it properly. Then please do question number 2. Then you would be able to understand how to calculate the pH value using the H plus ion concentrations. Now you would understand. So now when you have done the question, you would see the C, D and E are going to be alkalis. So that means they still have a concentration of H plus. So as you can see here, the H plus ion concentration is very low. So that means they still have a concentration of H plus ions. As a result, they become they are more. However, they have more proton acceptors. As a result, they are basic in nature. Their pH is into the alkali part, that is above 7. But because still they have H plus ions, we use that to figure out how much, what is the pH and what is the reverse also can be done the same way. So the H plus ion concentration can be found from the pH by going in reverse. So you would understand, use the calculator and see whether you can figure out how to do that. If you have any doubts, please ask me questions. So now you will have to do question number 3, and after that we will move to the pH of strong acids in the next video.